Yeah, and this is talking like, oh, just use a calculator. Classes, it's all like letters and variables and stuff. You test whether like someone really knows and get the answer. Like, that's cool. 7 stream streak, nice. Because today, it's Tuesday. That's cool. Tuesday. Second to last educational streak. Why am I getting ads for each? Maybe because it's, probably. I saw 5 a.m., which is, I think, or 10 hours, I guess. But that's hilarious, Mondo. What? You're kidding? It's because we're in the just chatting category now, which is probably a bunch of like simps and thirst traps. Like ads. Give me a sec. Prioritize the traffic somehow. Needs. I could probably cut one of the streams down. Like for these like buffering issues. Man, do I need to cut the Discord? I can cut the Discord. I don't want to cut the YouTube because I just got the YouTube working. Bitch. Drop due to network. What's taking all our network these days? Oh, also, why is this outputting at 7K? There we go. Okay, now it's fixed. Yeah. Wow, that's super weird. I already have, I'm pretty sure, on my stream settings. Yeah, I know it's not buffering now. And I just looked at that. The bitrate went back down to 3K. It was outputting at 7. I do not have it set. Yeah, no, I have it rate controlled to 3. Why does it... Okay, so that's something with Twitch and OBS then. Because actually, OBS... I don't know. For those that stream or think about getting into streaming, bitrate is a very important thing for, like, the quality of the video and stuff. Especially if you're doing, like, fast movement. So, like, FPS, like really intense video game stuff. First-person shooters or whatever. You want high bit rates to be able to catch all the frames and all the details that are happening. Here, it's just my face and me teaching you math and science, so we don't really need that high of bit rate, which is okay. But for some reason, it was jumping, saying it was putting out 7. Just shouldn't be putting out 7. Yeah, 7 will choke my system. 3's okay. What's up, Initial? Good to see you, dude. Yeah, exactly. 700 down with 15 up. It's fucking robbery, dude. Yeah, what the hell? That is straight robbery. I agree. It's because most people don't upload. And so I guess the cable companies, to save money, make it asymmetric. The whack thing is that, like, I don't have any alternatives. I can't, like, go to another provider that'll do this. My only solution is to go get an office and then get a commercial, like, internet line, which would cost like a lot of money. Anyways, plans I guess for 2025. Okay, so yeah, we got a lot of questions today. We'll go through them. Oh, other quick news. We're gonna have a Golden Hour AMA podcast guest for Friday. That's 6 p.m. Pacific, 8 p.m. Central, 9 p.m. Eastern. And it's a really cool guy. Here, let me pull the page up. I just announced it today. Yes, here it is. One second. Let's show it here. Olaf, go away, please. Discord. Yeah, there we go. Okay, cool. Yes. So, his name is Perry. He's a really cool guy. And he runs a company called Ocala, which specializes in providing college admissions advice and guidance and all sorts of fun stuff to kids that usually can't afford it, because yeah, college admissions coaches and counselors are like dumb expensive usually. But he's gonna come on our podcast on Friday for free. It's really nice of him. So please, yeah, in here, yeah, good Ace. I like this. Ace already asked a good question. Yeah, submit as many questions as you want here. I'll try to go through all of them with him. If I can't, I'll have ChatGPT pick the best ones from you guys. And whoever's question that Perry thinks is the best wins $20. Yes. Do I have Ethernet? Yeah, of course this is Ethernet. Yeah. We're just talking about like the modem connection, like for what it is. So yeah, that's gonna be a really fun time on Friday, and that'll probably be the last stream of 2024. Because then we're gonna go on winter break. But yeah, please, submit some questions. It's gonna be fun. And with that, yeah, let's questionable. What's up, Initial? You always can. You always can. What's up? All right, here. With that, let's start off the stream. Welcome everyone to Office Hours. Sexual Education. My name is Dr. Gold. Student help you out math homework, science homework. All sorts of fun stuff today. Welcome everyone. I hope you guys are having a good week with finals. We're here to help you guys out with any last minute questions. I would think teachers should end school by Wednesday, right? Wednesday, Thursday. Some of you guys are even off school at this point. But as our Canada friends were telling us, some of you guys have your exams after the Christmas break, which I think like is cruel. Like what? Why would you do that to someone? It's not very nice. Your school ends on Friday. Okay, cool. And when do you guys go back? Is it the Monday after? The Monday after? After New Year's. Yeah, January 3rd or something. Yeah. Oh wait, that's like a Friday though. I'm pretty sure. Yeah, isn't that like a Friday? Yeah, if we go to the calendar we got here. This is all our streaming friends and when they're streaming. Oh, you go back on the Friday? I would hope you go back on the 6th on a Monday. That's really weird for you to go back on the 3rd, which is a Friday. But okay, here. Let's do the first set of questions. First set comes from, looks like Ace. This looks like physics. What's up, Ace? Yeah, all right. A mass... You are going back on the 3rd? What? That's a Friday. Why would they do that? What, just come back for one day, then go back on the weekend? Yeah, they should have just given me the day off. What the hell? That's fucked up. What's up, Ace? Okay. A mass is on a spring at rest, 20 centimeters above the ground. The mass is pulled down 10 centimeters and released at time t equals 0, creating periodic up and down motion. It takes 2 seconds for the mass to return to the low position each time. Sketch a graph showing the height of the mass above the ground as a function of time in the first 4 seconds. Oh, this is pretty cool. This is actually also very math related. This is similar to, I think 12th Decade was asking about this. These are like sinusoidals and stuff, yeah. Okay. Well, this is called SHM, which is not Swedish House Mafia, but it's simple harmonic motion, okay, which refers to things in the universe that oscillate. Hey, what's up, Raven? Good to see you. Hope you're hope grading the math finals has been going well. But yeah, simple harmonic motion is stuff that just oscillates like back and forth like this. Yeah. Some examples of this, right? What do we got? I don't know if you guys have seen like a pendulum. Pendulum has simple harmonic motion, right? So if you swing here, let's get like a GIF. I want to see some images. Yeah. So something like this. So something like swinging back and forth. This is an example of simple harmonic motion. We could think of a spring up down. That's another one. This is another form of simple harmonic motion. So if you take like a mass and you attach it to a spring and you pull it down, it'll go up and down, up and down. Is this like the vibration created to make notes? It is similar. That's more a driven harmonic oscillation. Because usually you're... But yeah, you're right. Sorry. If you were to pluck something, you're exactly right. That is simple harmonic motion. Yeah. Oh, you're a university... Oh, that was math major guy. Okay, cool. Nice. Okay. I remember we had a couple new people yesterday. I'm sorry. I will solidify who is who after a couple visits. But welcome back, Violet. This was part of the finals. Oh, you had this? Oh, okay, yeah. So yeah, this is simple harmonic motion as well. Just a lot of things in life, in the universe, just do this. And the pattern at which they do this thing is a simple sine and cosine is what it is. Yeah, for sure. A watch clock is the shit used for hypnotization. Yeah, you're right. Yeah, it is. I want to show this. This is very cool. Where do they have like a nice graph of this? But yeah, so it turns out that the reason why things oscillate, well, okay, sine and cosine, which is, you know, this wave squiggly thing you guys see in math, is actually describing the component of like the horizontal component and the vertical component of a point as it goes around a circle at a constant speed. So here, this red line here, which is sine, is showing what the height of this green dot is as it goes around the circle. Okay, that can be thought of as the y position, right? You have a y position that's positive here, and then it's 0, and then it's negative. Whereas the blue graph, which is cosine, is showing the horizontal component of where this green point is. You can think of it as like the x-coordinate. And so they're basically the same, but they're just offset by a little bit. And it's just describing something going around in a circle at a constant speed. So I think it's pretty wicked that mathematical concept describes things in nature here, such as just pulling a mass down and having it bob up and down. It follows the same like sine and cosine pattern stuff. Although, yeah, in this case, the mass is just going up and down, so there's only one thing we're really looking at. But the height follows either a sine or cosine. Depends where it starts at. Okay. The mass is... So let's see. It's... I hate that they do this. Like, what? They say it's at rest 20 centimeters above the ground. It's kind of annoying that they do that. But okay, whatever. 20 centimeters, and this is it at what we would say is like t equals 0. It's then pulled down 10 centimeters, okay? So, oh, actually, sorry. This is it, like, at equilibrium is what we say. Equilibrium. And then here, at time equals 0, it's released when it's only 10 centimeters above the ground. And then what it's going to do is it's going to oscillate upwards another 10 centimeters above this. Oh, interesting. Well, so the wording here is a little weird, Shantrix. And I'm kind of assuming some things. One sec. A mass is on a spring at rest at 20 centimeters above the ground. I assume they're talking about this. I assume the mass is hanging from a spring. You're right that it could be like this as well. But then when they say, like, it's pulled down, I wouldn't really call this pulling it down. I would call it pushing it down. This is where the English is kind of weird, right? Because this, in my eye, is pulling it down 10. In reality, it doesn't matter. As long as you know what the equilibrium position is. And we'll learn this later in physics. There's a thing called Hooke's law, which says F is equal to negative K delta X. And what this describes is that the force on an object is proportional to the spring constant times delta X. And this is the change in position from equilibrium. And equilibrium is when the object is still. So in this case, the mass is just hanging there. In reality, this spring, if there isn't a mass attached to it, is going to be shorter. Yeah, forces, again, they do play a part, yeah. And so what your teacher can actually have you do is determine what this K is. And the way to get that is to figure out, okay, how much does the spring stretch from this equilibrium to this equilibrium when there's a mass attached? Because here, you have mg pointing down, and you're going to have kx pointing up. And these are equal to each other in order for this thing to be staying still. Yeah, but that's not the scope of this question, Ace. So I don't think you have to do this. So again, I don't want to introduce too many new concepts and confuse you, because all we're doing is just graphing this. But anyways, it says it takes 2 seconds to return to the low point each time. Okay, so that means at t equals 2, it's going to be right back where it was. Okay, which means that halfway in between, at t equals 1, it must be at the opposite end. So in that case, it's probably going to be here, which would be 30 centimeters, right? Because in order for this to do an oscillation, it's going to have to go up, past equilibrium, and then come back down. And it does that in 2 seconds. So from here to here being 2 seconds, that means halfway in between that has to be 30. Okay, how is it 30? Yeah, good question. Okay. So since this thing was pulled 10 away from the equilibrium, 10 down, when it's released, it's going to end up 10 above the old equilibrium. Yeah. Yeah, everything oscillates around this equilibrium. And then what we know is that here, so halfway in between these time points, which would be t equals 0.5, it's going to be at 0. Huber, how do I prepare for my midterm tomorrow? Practice, man. Did your teacher give you a review sheet, Huber? You know, I tell students, you know, the best way to prepare for any sort of exam is to do previous exams or do homeworks or do quizzes. And then if there are certain things that don't make sense to you, ask for help. That can be me. That could be ChatGPT. That could be, I don't know, like Chegg, maybe whatever. Like, you can find help. It is. It's like that, but Jeff is correct. It's the opposite. It's -1, 0, 1, 0, -1. Oh, proofs for geometry? Yeah. Yeah, those are tricky for sure, but they're patterns. Like, you can see that you always end up proving something by angle, side angle or something, right? But yeah, this is similar. So what we would say is, like, this is probably our 0 point, right? This is kind of like the -1, and then this is kind of like the +1. Okay. So, yeah, let's graph this. So, we have the time points, and we have the positions, right, that things are going to be at. And they want it to do it for the first 4 seconds. Okay, so we know what it does after 2 seconds, so then it's just going to repeat itself for the next 2. So, yeah, let's start graphing this. Sorry, Swedish House Mafia, you gotta go away. Okay, let's put some times. So here, let's put like amplitude, or we can put y. Let's just put y on it, and let's have this be t. And then this is going to be 0, and then we know we're gonna have 1/2, and then we're gonna have 1, and then 3/2, and then 2. And then 5/2, 3, 7/2, 4. Okay, good. And everything is oscillating around this height of 20. Okay, so that's going to be our kind of our midline is what we're going to say. So this is 20, and then we know it gets pulled down 10 below. It gets pulled up 30 to 30, which is 10 above that. I think we've done this. I've shown you how you do this. This is the midline where things are going to oscillate around, and then I'm going to have this be kind of like the max line, and then I'm going to have this be the min line. You guys did this? Yeah. I think we did do this last week, right? Yeah, we did this. Yeah. Okay, then you just plot points, right? So at 0, it's at 10. And here, I'm going to use purple for this. Yes, I'm going to use a solid thing. Okay, so here it's at 10. At 1/2, it's at 20. Or here, we can start drawing things, right? And then at 1, it's at the max. At 3/2, it's back down to 0. And then here it's back down to 2. And then here, can I want to see if I could select all these. Oh, I can't do it. Limits of this software. It's okay. Okay, cool. So that's our graph. And then, right, if we wanted to draw some lines in between this, right, this would end up looking something like this. Okay, cool. So now they want us to write an equation for this graph. So this is either going to be sine or cosine, okay? Technically, you can write it as either. It just makes a difference on what you're going to put in for the phasing and maybe like some negative amplitudes and stuff. Yeah. Cosine but reflected would make sense. Exactly, right, yeah. So what I like to say is if it starts at 0, or it starts at the midline, sorry, then you're going to want to use sine. And if it starts at a max or min, you're going to either want to use cosine or negative cosine. Okay? Positive cosine is just a 1 in front of it, right? Because cosine of 0 is equal to 1. This is where you have to kind of remember your the circle thing. What is it? The unit circle a little bit. Yeah. So we're gonna let's do this as cosine, but cosine of 0 would be the maximum. I need it to be the minimum, which means we're gonna use negative cosine. So I'm gonna say, okay, cool. This is y is equal to negative cosine, and then we need to know here. Let's remember is the sorry. Let me get the general form of this. So the general form, right, is y is equal to a cosine, and then it's omega t plus phi plus, I don't know, b. Yeah. What happened to my Discord stage? The fuck? Discord? Give me a second. I don't know why I did that. Discord just messing up these days. What's up, Smash? There we go. Okay. We're back up. Yeah, I didn't leave the call intentionally. All right. Remember, A is amplitude. This refers to like how much this thing wiggles away from the middle. In that case, it's 10. And then we're gonna have a negative in front of the cosine because I wanted to start at the minimum. So I'm gonna say this is negative 10 cosine. We got to figure out omega. Omega is equal to is it this? Is it period over 2 pi? No. I think it's 2 pi over this. Maybe I'm like super wrong. Oh, no. I always have to remember this. Omega equals 2 pi f. F is 1 over t. Oh, so it is that. Okay, cool. All right, period refers to the distance from like a valley to a valley or like a peak to a peak. In that case, that's 2. So that's just equal to 2 pi over 2, which is equal to pi. Phase shift, that's if like this thing starts moving to the left and the right, which it's not. We're having it start like at the standard spot. So this is actually going to go to 0. And then midline here refers to where this thing oscillates around, which is 20. So at the end, we get negative 10 cosine, and that's going to be, pi t plus 20. And that should be it. Oh, yeah, sorry. You guys do things in degrees, Ace. You're so right. Okay, that's fine. It's so funny because especially in physics, we do not use degrees for this types of oscillation. We use radians. It especially becomes important when you start doing like R omega equals V. This needs to be in radians per second in order to convert to velocity. But okay, sure. Okay, so instead of that, we'll use 360. 360. Okay, so that's 180. I don't know. I have some qualms with that. You shouldn't be using degrees. I get, because I guess your teacher hasn't really taught you radians yet, so they're kind of kicking the can down the road. But yeah. Okay. Anyways, yeah. There you go. Nice. Good job. There you go. Ding 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 ding. Yay, Olaf. Yeah, okay, cool. Nice, good job. Here, let's have about 12. Back at 3 coins. Yes, I'll get your rewards later today. Alright, I kind of just woke up. Alright, where is 12? Is 12th around? Oh, I don't see him. Where's Sir 12th? Nothing, I need to buy the shop right now. Okay. Yeah, what up, 12? Okay, cool. Alright, let's do this. A propeller on a ship rotates to put the ship in motion. The depth of the propeller in the wave can be modeled by this, that's cool. Where D is the depth in meters and T is the time in seconds. What is the period of the function and what does it represent in the situation? Oh, this is kind of cool. So yeah, this is pretty similar to what we were doing earlier with Ace. So I guess like here's like the propellers, right? Kind of what we think. I'm like trying to draw propellers. But yeah, so this thing is like, for instance, like spinning around. So, and then this thing is whatever the depth that it's in the water. It's like this. Yeah. So this thing will like go down and come back up. And this is cool. This is why it's a sine or cosine function, guys, right? Because it's literally, it's doing this. It's the height. The height of it. So the propeller, right, in the green is spinning around. And then the height, which in this case is the red curve, right, is oscillating like a sine graph. Okay. Cool. Okay, that's cool. All right. So what is the period of this function? Let's try to do it, right? So, right, we have D is equal to 5 sine 30t plus 1. Oh, wait, sorry, the plus 1's on the outside. And then remember, right, the general form you had here, which was... did I write it here? Yeah, I wrote it here. Come back. This is like the general form. Or like, this can be sine or whatever. Yeah. Okay, period. Right? Let's try to remember this. So, this, right, the omega here is equal to 360. In this case, degrees, I guess, kind of makes sense because they're putting 30 on there. It's a big number. Yeah. So what would the period here be? See that this thing is the same as this thing? This looks like this. That means this is equal to 30. Do you see how you can solve for the period here? What would the period be? $12, very good, 12. Wow, just like your username, dude, 12. That's dope.
That's dope.
Good, yeah, period equals 12. Okay, what does that represent? Yeah, cool, it's 12, but what does 12, what does 12 mean? 12 what? 12 cookies? 12 Ferraris? 12 Lambos? I would take 12 Lambos over 12 Ferraris. Yeah, what does the 12 mean? Means the period, but yeah, so they say, what does it represent in the situation? They mean in real life. Like, if you go to your mom and be like, the propeller has a period of 12, you can be like, cool, what the fuck does that mean? Like, what does that describe about the propeller? Maybe it would help to remember what period means. Now, period doesn't mean the depth of the blade. So let's remember this. Okay. So period is equal to the amount of time for one complete oscillation. Okay? That's what period is. Period is the amount of time it takes for something to do a rotation. In this case, it's the amount of time it takes for this green thing to go from like the top to the top. All right, you see how the red top, then it goes down, then it goes back up to the top. All right, peak to a peak is the amount of time it takes for the green thing to do one oscillation. Okay. So, in this case, remember, we're describing the depth of the propeller blade, I guess, which is this. This is the propeller. They should have said the blade, not the propeller. The propeller's the whole thing. I hope the whole propeller thing isn't moving up and down, but the blade is. So what this means is it's 12 seconds for one rotation of the propeller blade. Oh, okay. Yeah, no, yeah. They do say propeller blade here, but they don't say here. They say the depth of the propeller. They should have said blade. Yeah. No, you're right. Yeah, you're okay. Yeah, okay. Right. So, yeah, one rotation of the propeller blade takes 12 seconds. That's what period means. Okay. All right. What is the amplitude of the function? What's that? Amplitude, let's remember, is this thing. So that's going to be 5. Cool. 5. Awesome. Love that. Okay, what does that represent in real life? You can't just say it represents the amplitude. Close, Shantrix. It represents the change in the height of the propeller from the midline to the top and the bottom. Yeah, okay, yeah. So what this means is like, okay, so this whole thing is 1 meter deep, is what we say, from like whatever the water is. Okay. The 5 here, right, is how much this is going to oscillate around. It's going to oscillate 5 up and 5 down from that 1 meter deep. So interestingly enough, this propeller blade is going to come out of the water. Because at its maximum point, right? Or actually, no, sorry. Yeah, no, it is. Okay. So this is also kind of weird because they're measuring depth, which is the down direction, as positive. It's kind of annoying. Okay, because look, they say the depth is equal to this 5 sine plus 1. Okay. So let's actually just graph this. Let me just graph this for you guys real quick. 5 sine 30 plus 1. How do I want to do this? I could do this on a TI-83. I could also do this on Desmos. Yeah, let's just do it on Desmos. Graph. Okay. 5 sine 30 30t plus 1, I think, right? Is that what it is? Oh, I need y equals. All right, whatever. Oh god, that's terrible. How do I set the window on this? Oh, settings. Here we go. X-axis. Let's go from 0. Oh, interesting enough. Yeah, I need this in degree mode. Yeah. Let's do this for, I don't know, 60 seconds. And let's have the height go from -5 to 7. Okay, cool. I like that. And then, yeah, let's have this just 2 oscillations. Okay, cool. Is there a way for me to like just screenshot this? Oh, nice. Did it literally just do that? Oh, this is pretty dope. All right, here we go. Yeah. Okay. So here we go. So this is the graph of 5 sine 30 plus 1. Because look, here is the plus 1. Okay. Where this is depth. Okay. And because it's 5, because the amplitude is 5, that means it's going to go all the way up to 6. And it's going to go all the way down to -4. So this is going up 5, going down 5. And so this is going to be -4. So what this is telling you is that the depth of the propeller blade is going to oscillate 5 away from a mean depth of 1. So at some points, the propeller blade is going to be 6 meters into the water, and in some points, it's going to be -4. Now, it may seem weird to say that the depth is -4, but remember that, like, depth is measuring, like, how far down something is. So this would be positive depth. Negative depth is then going to be outside of the water. This is where it's kind of tricky because we're switching like the signs on things. So yeah. So what you can say is that the amplitude is 5. That represents how many meters in depth the blade oscillates from the mean depth of just 1. Sorry, this is not 6. This is 1. Yeah. Okay. So then when they ask for what the range of the function is, right? Well, the range of the function is, like any function, is just what's the min, what's the max. We already said that the midline was at 1. The amplitude is 5. So the lowest it's going to go is -4. That's 1 minus 5. And then the highest it's going to go is 6. That's 1 plus 5. So the range of this is from -4 to 6. -4, comma 6. Okay. And then it says, within the first 24 seconds, at what times is the propeller blade 2 meters below the water? Okay, that's cool. So 2 meters below the water means a depth of 2, is what they're saying. Because I assume depth equal to 0 is at the water level. Okay. So in that case, they want to know, this. And we said, right, within the first 24 seconds. So 24 seconds is 2 rotations, right? Because it was 12 seconds for a single rotation, right? And look here, this is 2 rotations, you see? 1, 2. So you can see here on the graph, right? There's going to be 4 locations where this happens. And we did do this last week. This is a pain in the ass to solve manually by hand. Are you allowed to use a calculator to just find these points? Because this really sucks to do by hand. Yes, but not a graphing calculator. Okay. Okay. It's possible. Yeah, Shantrix, yeah, what are you typing? It's just gonna get ugly. How will the teachers know if you have a graphing calculator? They're probably gonna check what calculator they're using. Because, okay, you want to see how I do it? Oh, that's cool. Yeah, I can do it. That's cool. Yeah, they are bitchy like that. Red Cross just wants to call me like crazy. That's fun. Okay. All right, we're eventually going to need to use this calculator, but not yet. Okay, so what I'm going to do is I'm going to set this equation. 5 sine 30t plus 1. And I want to know when the depth is equal to 2. Okay. So now I can start solving some things, right? Minus 1, minus 1. And then I'll divide by 5, divide by 5. So I get that 1/5 is equal to the sine of 30t. Okay. Should I do my assignment or practice math? Follow your heart, Raven. You know, you can vary it up a little bit. Little work, little play. You know, that's what my dad would always say. He'd be like, you know, work then play, work then play. Do an assignment and then have some fun. Math time it is. All right. So yeah, to solve for this, to get rid of the sine, we gotta take the arc sine on both sides. Okay. So what I'm gonna do is I'm gonna take the arc sine of 1/5, and that's gonna be equal to 30t. Now this is where things get tricky, because arc sine has a periodicity to it, which means that yes, it's equal to this, but it's equal to that plus 360. Uses the cast rule to solve this. What's the cast rule? I like learning things. Oh, okay. Oh, all students take calculus. Yeah, ASTC. Okay, yeah, I know that. Yeah, well, they're saying this, right? And that's where it's positive, right? ASTC. Yeah, all students take calculus. Yeah, that's how we learned it. But anyways, yeah. So sine being 1/5. Let's remember sine is opposite over hypotenuse. So that means that the opposite needs to be 1, and the hypotenuse needs to be 5. I like drawing it like this, okay? Now, when I take arc sine will only give angles in these two quadrants. That's just how the domain and range stuff is for arc sine. It'll only give you angles here. So, unfortunately, what it's missing is the other angle in purple, which is over here, where this could be 1, this could be 5, and then this one would be negative. But in both cases, the sine of this angle, or here, let me make them different colors. The sine of this angle and the sine of this angle are the same. If sine equals negative, then it's the bottom two. If it's positive, then it's the top two. Exactly right. Yeah. So you're going to get a number for whatever this is. And then this number is going to be 180 minus this number. Because what happens is 30t is equal to this, but it's also equal to that plus another 360 technically. You can keep going around as many times as you want. So it's really equal to this plus 360. But then it's equal to this one as well, which is 180. And sorry, it's 360n is what it is. N is the number of times you can rotate around. It's also equal to 180 minus that angle. That refers to the pink one, plus 360n. That's also equal to 30t. Because then, yeah, it could also be this angle, but keep going around 360. Okay? Alright, so all I have to do is just divide by 30. Divide by 30. So that's going to be sine inverse of 1/5 plus 12n, right, is equal to t. And then what's that? 6 minus, I forgot this over 30. My bad. Thank you. You guys do it a little different? What do you do? How do you do it differently? I'm curious. Wait, what? She says the depth is -2? That's wrong. Depth is below the water. What? Excuse me? She fucked up. Yeah, no, your teacher messed up. Your teacher messed up here. No, you're not wrong. You're correct. Your teacher fucked up on the wording. Depth is how deep it is. That's how, by definition, depth is how much you are below the water. Yeah, it's like 2 negatives. Exactly, Shantrix. Yeah. Okay. Right, she gets the time for each of them, and then she adds 12n. Yeah, that's fine. So, I mean, that's what we're doing here. So we're going to get a time for this, we're going to get a time for this, and then we're going to add 12. As long as the times are below. Yeah. Yeah. Yeah, no, your teacher's wrong. And that's okay. Like, teachers are humans. They can be wrong too. But yeah, if we say that D is the depth and we want to know 2 meters below the water, that's when D is equal to 2. It's not -2. They fucked up so many wordings in the review package. That's annoying, dude. I know, especially at your age, because you start thinking that, you know, teachers are God and, like, they should always be correct and nothing should be wrong. I remember having this realization. It was in my calculus class, actually. I was like, oh, man, life is a lie because my math teacher is actually wrong now. Well, and this is why it's also important, and I say this to all students, go get a copy of your exam. After you take it, so many students will be like, I got my grade, whatever, and they'll just leave it. But if you didn't get the grade you wanted, always request that you can see how they graded it. Because if she's pulling some bullshit here where depth is somehow negative, then no, that's wrong on their part. And you have a right to challenge that. Yeah. 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 But anyways, here, well, I'll get you the answers I got so you can check to see if they're correct with what you got. Okay, so sine -1 of 0.2 divided by 30. So that's 0.38. So that's going to be 0.38. And then 12.38. So we're just going to add 12. And then if we do 6 minus that number, right? That's going to be 5.62. And then 17.62. Yeah. Okay, those are the two. What's up, Amog? What's up, buddy? You want to come say hi? Say hi. What's good? Why not, dude? How's it going, Beta?
It's good. It's going good. How are you?
It's good. How's are you done with finals? Are you done with your classes? What's going on?
No, I got finals January 20th.
Bro, all you Canadians getting fucked, bro, dude. What? Y'all have to do exams after Christmas? That's so un-American.
Canadian? I'm from Washington, bro.
You're basically from Canada.
Oh, okay.
Dude, it's basically, dude, Washington's basically Canada, right? Washington State.
It's close enough.
Yeah, dude, what? Yeah, you might as well be in Canada at this point. Yeah. Dude, that sucks, really? Everywhere else in the US, final exams are before Christmas, not after Christmas. That's so mean. Oh, damn. Skillium says, I thought D was about length. I don't know how I'm supposed to answer that. D in this case is depth. Does depth matter? In the case of propellers, it does. Yes, depth definitely matters. Oh, June end is also exams. Oh, you also have 2 weeks to prep. Yeah, but I wouldn't want to prep during like the winter break. I'd want to be chilling. Good to see you, Skillio. But anyways, okay, these are the answers you should get. Your teacher's wrong. It's okay. Go challenge them. Nice. No one uses winter break to prep in high school? Really? Yeah, I wouldn't. Good job, 12. I forgot the word chilling existed 3 weeks ago. Been packed. Okay, cool. That's a good question. Let's see. We got some other good ones. Let's run through them. Shantrix. Oh, you got more fun like geometry for me, Shantrix? Yeah, you're good, Smash. What do you need help with? I'll prioritize if you have a final exam tomorrow. That's okay. Smash, if you want help with calc, can you post a screenshot in help screenshots? Yeah, there you go. Thanks, Amog. Thank you.
Anytime.
Yeah, anytime. Yeah. What year are you in, Amog? Are you junior, senior? What's going on?
I'm a junior.
Oh, okay. Junior was fun. Yeah. It's
It
like
was
the
not
last
fun.
hard... No, yeah, I was about to say junior year was my worst year in high school. But it's the last hard year of high school. Because then senior year is a fucking, like, cakewalk.
That's dope.
We love senior year.
The lie, bro. All my tests like AP and IB.
Yeah, I know. Yeah, they're all the junior year. And actually, I was gonna show something cool. So this is we have a AMA guest on Friday, who's he created this. He was on Netflix actually. He was on a Netflix documentary. This guy, but he has like a college admissions like, I guess, company or something. So he helps a lot with college admissions, and he's giving you guys all advice for free on Friday. I saw on this website this thing called Chance Me, which is like find your chances to get in the school you selected. I want to ask him about this on the podcast, but you put in your GPA, AP classes, extracurriculars, community service, summer experience. You can enter in your scores here, and then you can select a school, and it'll show you what the report is. This is pretty cool.
Do you remember your
Right?
stats?
Do I know my stats? Ooh, good question. Well, I mean, my stats were like 15 years ago, but I think my GPA was, it says unweighted on a 4.0 scale. Probably around a 3.5. AP classes, I took like 12. How many? Oh, I see. How many are available and how many did you take? Interesting. That's an interesting stat. Okay. Let's say, for instance, my school offered 20 and I took 16 of them probably. Extracurricular hours, I spent a lot. Let's say 5. Community service, I also did a lot. We're going to put 5. Summer experience, probably 40. I did like an internship. How do you get this? Yeah, no, this is easy. It's right here. It's this website, ReckyRec. This is the guest. So on Friday, come by on Friday. The guy who runs this company is going to be on our podcast answering questions about college admissions. So if you want to submit questions and get free advice from this guy, like, please do so. It's in the Discord here. I made an announcement for all you guys. It's right here. But this is his name. His name's Perry. I met him at a tech event, mixer thing. And you can win money from submitting a question. If you submit a question and he likes your question, you get cash. So Go do it. How do I get that bond coin? Oh, I'll give it to you on Sunday. Don't worry. My reading score, that was a 700. My math was a 720. My ACT, I believe, was a 34. Let's see what my chances would be getting into. You guys pick a college. What college should I go to?
University of Washington.
University of Washington. Okay, let's go check it out. Washington University, University of Washington at Seattle. Here, let's see it. Okay. So GPA. So my average, school's average is 3.99. Oh, okay. So cool. It shows you like where you're doing well. So, okay, I need more extracurriculars is what it says here. My community service is super low. Oh, ew. Who's doing 80 hours of community service? Excuse me? Summer experience. My ACT score is better than the average. Nice. English is about the same. Cool. This is where you see whether you're comparable on like SAT scores and stuff. Oh, do I have to go back and enter them all in? That's going to suck. Ugh, I don't really want to do it. Okay. Anyways, yeah. No. So that guy's going to be on our podcast on Friday. So come on by. And ask him all the questions. I'm going to ask him about that app. I'm curious how that app works and where he gets the information from. But yeah. Chick Korea says big test on set theory and bool. Ooh, good luck. Good luck, Chick. I don't really know much about set theory, but if you want to know some people that do, there's a list of all the other math streamers. And I think, yeah, Zach, E to the 2I Pi, is streaming later today. So here, if we go to calendar and we click on the calendar here, I think Zach is streaming later today. Let me see. Yes. So this stream right here, Zach's stream right here, this is the one you want to go to if you want to ask him. I don't really know much about set theory, so I can't really help you there, unfortunately. But he does. And so he can definitely help you out if you have any set theory questions that you want to, go through before your final. Oh, thanks, Smash. Thanks for posting those. Okay. Let me, here. Let me help Smash real quick, because he has finals tomorrow. And then Shantrix, I'll do your fun question. And then we got Ayush, and then I got a Darsh. Yeah, I got all you guys. Don't worry. We're going to do it. Just number 2 on the first pick. Okay, cool. Let's see it. I can help you out. Yeah. If it's someone's like first time and they have an exam tomorrow, I tend to let them skip the line just so I can make sure we do their question. Okay. Find the area of the enclosed region enclosed by the following lines and curves. Include a sketch of the boundary region, blah, 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 solve. Okay, cool. Okay. I want to try and graph this first, if that's cool. So g of y is equal to 0. Oh, whoa. Ugh. What? Oh, so they want it on this graph, y versus x. That's so annoying. Really? We don't want to do that. Okay. F of y. So this is the x coordinate, Smash? Or can I just relabel everything as x? Because honestly, it doesn't matter. I could say that this is y and then this is x. That's totally legal, right? Yeah, I'm pretty sure. No, I mean, this is a good one. Oh, just need to know the concept? Okay, fine. Yeah, easy. Okay, fine. We'll do this one. This one's a little bit easier. So we have f of x is equal to this. This looks like a quadratic, which if I wanted to graph this, I would first want to complete the square to make this look nice. Do you remember how to complete the square? Not really? Okay, well, I'm gonna teach it to you. So here, we have f of x. Just, I want to get this into vertex form. Just because it'll look a lot nicer. This is why everyone who's yelling on my TikTok, just use the quadratic equation. No. This is why you need to learn how to complete the square. I'm going to pull the negative one out. first. So I'm gonna say this is equal to -1, and then this is x squared. Yeah, exactly. Shantrix, you saw it, bro, dude. I was getting mad. I was like, and also I always like move this +1 like outside is what I do. All right. Then what I do is I take this number, I divide it by 2, which gets me 2. I square it, and then I add it and I subtract it. So this is +2 squared minus 2 squared. Okay. Then this part here becomes a perfect. This is a perfect square trinomial, where specifically this is going to be x. So it's whatever this is, plus or minus whatever this is, squared. And then we still have this. We still have -2 squared. And then this is all still inside the big parentheses of the -1. And then we still have a +1. Okay, so the last step is to multiply through. And so that gets me -x minus 2 squared. This becomes -4. -1 times -4 is +4. +4, 1, plus 1 is 5. So this is my equation, right? -x minus 2 squared plus 5. Why this is unique, Smash, here is I know that the vertex is now at 2, 5, and it's pointing down. Okay? So now when I graph this, right? 1, 2. I know it's like right here. And it's probably doing something like this. It just helps me to graph it. Does that make sense so far, Smash? I ran through that kind of quick. Yeah. If you want, like, again, some additional help on how this works, I have a video on YouTube with it. Where's my studio? Content. Shorts. Here. This is... Now let's look at how to complete the square when things get harder. And the first coefficient is
b
1.
squared over 2a.
We're gonna dive right into this.
Yeah, that's also like the x-coordinate, but you should learn how to complete square. Just know how to do it.
Adarsh, not yet. I'm helping this student out because they're new and they have a final exam tomorrow. Just one sec. Don't worry, I'll get to yours, Adarsh. I haven't got over yours yet. He's just a chill guy for real. He is. Okay. So that's the first graph. The next graph is x plus 1, okay? Which is going to look just like a line that looks like this, okay? And so they want the area in between, which means they want this, okay? Now, in order to find the area between two curves, what you're going to want to do is do an integral from what I call like the starting point, which is going to be A, to the ending point where they intersect, which that's going to be B, and then it's whatever the function on the top is minus the function on the bottom. In this case, the function on the top is this one, so that's going to be f of x, and then the function on the bottom is going to be the g of x minus g of x, and then this is just dx. Okay. The very first thing I did the completing square here to graph this because the teacher asked you to graph it. You can actually do this without graphing at all. The graphing helps to see like which one's on top, which one's on bottom, but you can also do this without. And what you need to do for the first step is always figure out like where these things intersect. Okay. Because you need to figure out this A and B. These are the bounds of your integral, Smash. You need to figure out where you're going to start integrating stuff and where you're going to end integrating stuff, which is usually where they intersect, the two curves. In this case, it gets a little bit trickier, I think, because you have to kind of like really see what's going on. Sorry. Sorry. Let me give you permission so you can say bad words. Give me a second. There you go. You can say bad words. Do it again, Smash. Sorry. Yeah, we do that to prevent, like, new people coming in and just spamming the N-word in my Discord. You do not use the discriminant to find the intersect. Oh, so you can graph everything? Oh, then fuck this. Yeah, whatever. I mean, it's still useful. What's up, Equity? Wagwan, my fa. It's still useful to know how to do this. But no, it's not my bad. No, because this also teaches students something, you know. Still useful to know when you don't get a calculator right. Yeah. So you need to know what the bounds are, which is like where these things intersect, okay? And the way to do that is to set these two functions equal to each other, all right? So you can do negative x squared plus 4x plus 1 is equal to x plus 1, all right? Now, when I set these equal to each other, watch what happens. -1, -1, those go away. Minus x, right? I get negative x squared plus 3x is equal to 0. This is super nice because this is an easy quadratic to solve. I can just factor out x. So, and actually, I can factor out the -1 as well. Let's just multiply everything by -1. So this becomes positive. This becomes negative. So now I can factor out x, and I get x times x minus 3 is equal to 0. Now I know what values of x this happens for. This happens for x equals 0, and this happens for x equals 3. So those are my two bounds. So when we go from A to B, we're now going to be going from 0 to 3. And then it's going to be this function, which is negative x squared plus 4x plus 1, all subtracted from this function. So that's minus, you should put parentheses around here, x plus 1, because this minus is going to distribute. And then it's just dx. And you can kind of see, right? This thing probably intersects at x equals 3. And it also intersects here at x equals 1. Or x equals 0, sorry. So now combine things, right? So this is 0 to 3, negative x squared plus 3x. Right, that's it. Okay, cool. So that's negative x cubed over 3 plus 3x squared over 2 from 0 to 3. So that's negative 27 over 3 plus 27 over 2 minus, and then you plug the zeros in, those go away. Yeah. So I think that's it. Well, it's just this, and then like simplify this. Something with fractions. I don't want to do it. Multiply 1 by 2, multiply 1 by 3. I think you get like 84. No, sorry. 81 minus 54 over 6. Oh, okay. Right? Yeah. Can I explain number 4? Let me see real quick if it's easy. Ooh, revolving? That's trickier. That's definitely trickier. What is the ACT? The ACT is a standardized exam. Yes. I need to do a video on these, man. I do these so often. Okay. Real quick how this works. ACT is math, science, and I think there's a little bit of English. There's a lot in it. Okay, it says y equals 0. So that's this line. X equals 2. That's this line. And then 2x squared. So that's going to look something like this. Where, again, you want to find intersection points. So this is going to hit at 0. And then here, when x equals 2, y is going to end up equaling... Because this is 2x squared. So when you plug 2 into that, this is 8. Okay. All right. Okay, if you're revolving around the y-axis, okay, revolving around this, that means you're going to be doing basically like this thing. Well, wait a minute, one sec. And you're getting this area. This is what you want. You want this area. And so, if you're revolving around here... Okay. Does your teacher make you use shells or discs or washers? There's different ways to do this. Well, yeah. Anyways, the way to think about it is that you have like big discs and then like inner discs. Yeah, okay. And you're taking what the area of these things are and subtracting them from each other, and then you're moving up in this direction. Okay. It's a trickier concept to explain quickly, but in general, if you're revolving around the y-axis, in this case, your integral is going to be dy. And then what it's going to be, so in y, you're going from 0 to 8. So we're going this way, and we're building circles. So this is from 0 to 8 dy, and then it's pi, and then it's r outer squared minus r inner squared. Yeah, exactly. So yeah, whatever you need to describe the radius in terms of y in this case. So here, instead of saying y is equal to 2x squared, I'm going to solve this for x. I'm going to say that y over 2 square rooted is equal to x. Technically it's plus or minus, but I only care about the positive one, okay? So this describes our inner, right? That describes what the inner circle is, but because it's closest to the axis of rotation. And then the furthest, the r outer, which is the pink one, that is always going to be 2, right? Because you're always using this thing as your border. So yeah, that becomes the integral from 0 to 8 pi, and then it's going to be y over 2, no, r outer squared, sorry, is 2. So it's 2 squared minus y over 2, and then it's dy. And at this point, just do the integral. Does that make sense? Okay. But if you have to do it about the line x equals 2, okay, so now now this is easier, because if you're revolving around here, right, now you don't have like a hollow part, right? You just have a cone at this point, okay? So this is even easier. So this is the same thing, 0 to 8 pi, but now I don't have 2 circles. I just have 1 circle. And so what you need to know is, okay, this is where it gets tricky though. Here, let me zoom in and show you. Is that you need to know this distance, okay? Which is always equal to 2 minus this distance, the green distance, okay? And this right here, right, is the square root of y over 2. That's what we had, right? Yeah. Okay. So now, when you're doing pi r squared dy, your new r is 2 minus the square root of y over 2. And then this is dy. Does that make sense, Smash? Oh, and then this is squared, sorry. Right, yeah. Yeah, so this right here is R. Moog says, Gold, do you do ethics? I'm doing this ethical dilemma for talk. I don't know what talk is. TikTok? Yeah, that would be the end of the problem. Just do the integral. Oh, theory of knowledge. I already did it, but the animation I made is hella goofy. I have the grade to spare, so make sure it's at least interesting. Put some memes in there or something. Okay. Cool. If that makes sense, Smash, let me help out a couple students have been waiting, and then if you're still around, I can help you out with number 5 and number 11 later. Those are good ones. Yeah, put the chill guy with the low taper fade. Yeah, that's a good one. Okay, here, let me help out. Let me do Chantrix. Yeah, great, cool. Yeah, hang around. You're good. Good to see you, Smash. You get a bond coin for asking a question. All right, let's see. Yes, and Adarsh, you are... Well, Ayush is technically next. Is that you? Who's Ayush? Ayush is someone in my stream. And then it's Adarsh. And then Ace. And then I'll go back and do smashes. All right, here we go. WXZ has WX equals 4, WZ equals 3. Yeah, okay, cool. Thanks for waiting, guys. Yeah, it's busy during finals. There's a lot of students that need help, and I want to make sure they get help if their finals are tomorrow. You'll go after Ayush? Okay, cool, man. WX is 4, WZ is 3, and ZV is equal to 3. Oh, this makes a square, right? Can we draw that to scale, Chantrix? I think we can draw the scale, right? Well, it doesn't look very square. Wow, not drawn to scale. Okay, whatever. This is also 3. Then 4 is this whole path here. Okay, cool. The rectangle is curled without overlapping into a cylinder so that it slides W, Z, and XY to touch each other. Okay, so this like revolves around onto this. In other words, W touches X. Okay, blah, blah, blah. The shortest distance for W to V... Oh, ew. Oh, wow. Okay. The shortest distance. I kind of do. Okay. I think the main thing here, right, is that... Okay, so let's look at from like a top down. This is a good question, Chantrix. I like this one. So we know the total distance when W goes back down to when W hits X, that's equal to 4. Yeah. So like going all the way around here, that's equal to 4. But we want to know the distance from this point here and another point that is 3/4 of that. So that's going to be like this point, like right here. And they want to know like this. Right, let's put a different line for this. Yeah, okay. So, I need to kind of know this then, right? Is that kind of what I need to know? Because I already know what this is. Right? That's going to be 3. And then okay. Let's try to look at this top part like this. So this is my point, and then my pink point below is here, where it's 3/4 of the diameter, right? Because you see how like the whole diameter is going to be pi times 3, but then this is only at 3 pi. Or no, sorry. Oh, almost, yeah. Oh, what's up, Zach? I had someone asking about set theory for their final, Zach. I told them to go to your stream after this. What's up, Kate? Good to see you too. All right, so yeah, let's just get the angle of this. I just need this distance, I feel like, right? I just need this. Set theory. Yeah, I figured you know more about it than I do. I know absolutely fuck all about set theory. I forget where it was. Who was it? It was, oh, Chick Corea. Here, I'll just tag both of you if they're still there. There's their stream. Chick, if you wanna see him. Yeah, it's it's a chord. Okay, so we know that pi times d is equal to 4, right? Because this whole thing is 4, and it's made into a whatever. So, and then d is 2 times r, right? So I can divide by 2. So r is equal to 2 over pi. Okay, cool. All right. So now we just need to know this distance, which I don't think is too bad. So this is 2 over pi. This is 2 over pi. And then the distance to the chord, I think, is going to be related by, like, whatever this angle is, right? Because I know this angle is equal to this angle. And so whatever this angle is, we can figure that out. Because we know that going around here is 4, going to here is 3. So this must be 3/4 of 360 degrees. Okay. Which means it's only 1/4 of it here. Okay, so this angle here is that pi over 2? Yeah, I guess it is. Oh, that's silly then. Because pi over 2 is 90 degrees. Does that make sense? Femvox just says 18. Wait, you know the answer is just 18? You know this is all just 18, Femvox? Yeah. Okay, yeah. Okay, so look. So this whole thing, right, gets made into a cylinder, right? Where the X and the W point end up touching each other, okay? So I know that the total circumference of this circle is 4, right? But the amount that we need to go to get to this point is only 3. So going to here is 3, going all the way around is 4. So that's a 3-to-4 ratio in terms of the arc distance, arc lengths, right? And the arc lengths are directly proportional to the angle in terms of 360. So if I'm only going 3/4 of 360, that's just 270. Yeah, which is the same thing if I'm looking at the inner angle here. That's just pi over 2. Okay. So then I literally just have a 45, 90, which is nice, right? I know this is 90. This is 2 over pi. This is 2 over pi. So this length is going to be 2 squared of 2 over pi. Is that right? No, not over 8, sorry, over pi. Yeah, I think so. Yeah. 8 is 2 root 2, right? Yeah, okay. Okay, cool. So now we know this distance, right? This distance is 2 root 2 over pi. And now to find the blue distance, it's just this squared plus this squared square rooted, right? So that's just going to be 9 plus 8 over pi squared, all square rooted, should be the distance. So if I want that over the same units, right, that's 9 pi squared plus 8. Yeah, over pi squared. Which, yes, 8 plus 9 plus 1, 17, 18. I think it's 18 as well. Femvox, I think it's 18. Is that the correct answer? Is it 18? That's super cool if that's the answer. I'm curious what the solution was for this one, Shantrix. This is from some sort of Pascal question. I know it is. Oh, he's gonna go find it. All right, cool. All right, Shantrix is gonna go find the answer. See if we're right. Meanwhile, sorry, what is Ayusha's name? Oh, that's Reki Rek. You're Ayush. All right, cool. I'm gonna change your nickname so I know who you are. Ayush. Reki Rek. We'll get your question in. Then we're gonna do Darsha's, and then Aces, and then I'll do another one for Smash. Yep. Coming up. I'm just waiting to see. Shantrix is finding the answer for the other one. Let's see. Vertical tree stands on the side of a ski run. The angle of inclination. Oh, wow. There's a lot of stuff going on here. Okay. Angle of inclination and, like, angle of depression, right? Actually, I can draw angles that are actually correct here. One sec. I can get a 40-degree angle. Where is it? 40 degrees. There we go. All right, let's see. Question 23. Let's see if we were right on the other one. I'm curious. Answer was 18. Nice. Sick. Very cool, Shantrix. I'm glad we got that right. I like these Shantrix. These don't hurt me. Like, I'm able to do these questions. And that's cool. Yeah, they got the 90 degrees. Yeah. Yeah, very cool. Very cool question, Shantrix. I like that one. Good job, Femvox. It was 18 as well. Yeah. Okay, cool. All right, so let's draw like our little ski slope here, right? Let's draw a ski slope. Thanks for the follow, by the way, Trippa. So this is... I did geometry, yes. Celebration for me, dude. I did geometry correctly. Okay. Okay. Angle of inclination is always like the angle, like going up from what we say is like the horizontal. Angle of depression is this angle, and so it's like how far below a horizontal you are. That's angle of depression. So, yeah, 40 degrees, when the angle of elevation of the sun measures 65. Based on the post-exam discussions, my predicted grade on the mechanics file is 100%. Yeah, good job, Laz, dude. Nice, good job. Good job, Laz. Yeah, what are you saying? Like, I finished it hella early, I feel like I did badly? False. Yeah, I know you did well. Okay, this is kind of tricky, though. Okay, so this needs to be 65. Okay, so 65 degrees here is where the sun is. Draw the sun. Happy sun. Okay, sun's chilling here. The tree casts a shadow 75 meters down the slope. Oh, interesting. Now, I assume the tree goes vertical regardless of the slope of the ski slope, right? What's up, Famished? Yo, get more creative. I like cheese balls. Yes, Shantrix. Yeah. Oh, wow. Shantrix. Yes. The awesome face. Yeah. Who do I know has been on the internet long enough to know what that face is? Yeah. Okay. So this is a shadow that gets casted 75 meters down this way. Wow. That's a weird ass question, dude. What? Okay, 75 meters. Oh, I use Group World. But I've heard there are other options that are free, and I've been using Group World. I've been using it for like a decade at this point. Yeah, what kind of tree is this? All right, I'm sorry guys. I'll drop a better tree. The better tree. The Mr. Gold trees. Yes. Okay. I feel like I need to rotate things here at this point. Well, okay, first of all, I want to know what the difference in the angle is here. So I know that if this is 65 and this is 40, sorry, this right here must be 25 degrees, right? So really what we have is this. And then this is the tree. Right? I feel like that's kind of what's happening, right? Tree. Okay. This is 25 degrees. We know that this is 75. And I'm trying to figure out this. Do I have enough information for this? Oh, one sec. I think I know what this angle is. Yeah, okay, wait. If this is 40 degrees, right? For me to do this, and the tree sticks straight up. Yeah. At this point, this should be 50 degrees, right? This should be 50, which means this needs to be 130. Oh, wow. Which, okay, if this is a triangle, needs to add up to 180, right? That means this also needs to be 25 degrees. And now this is an isosceles triangle. Do you see how the angles are the same here? Ayush, right? Yeah, so I used this property. Yeah, right? So if this is 40 degrees and this needs to be 90 for the tree to go straight up, this needs to be 50. Which means if this is 50, and this is a thing you will do in physics, with inclined planes especially, is like rotating the frame to look as if whatever this axis is now just flat, horizontal. Right, and if that's 50, this is 130. 130 plus 25 is 155. 180 minus that is another 25. Now they're isosceles. This is also 75. And so, yeah, you're done. Wow, cool. That's dope. That's a cool question. Good job, Ricky Wreck. Yeah, you're welcome, dude. All right, let's do a Darsh's question. Yeah, if we're on a sphere, it could add up to 190 degrees. Yeah. Where's Jeff, dude? Where's Jeff with his love of non-Euclidean geometry, dude? Jeff, I know you like it. At this point, I'm just gonna use Microsoft Paint. Oh, don't famished. That is a big tree. 75 meters. Yeah, it's like what? That's like 7 stories. Like what's even like the tallest tree? Tallest tree in the world is 116 meters, so really not that much bigger. Wow, dude, look at this. Hyperion was discovered in 2006. It's located in a remote area of the park, and visitors are not allowed to see it. So wait, does it even exist? The exact location is kept secret to protect the tree and its ecosystem for damage. Visitors who attempt to see the tree risk a $5,000 fine and 6 months in jail. Dude, stop, bro. What? Why are they... I get it. Humans are just fucking awful people. And so, yeah, it makes sense that we would probably screw this thing up. But, wow. Look at that. That's the tallest tree. Yeah, 75 meters is...
Paper.
Imagine what?
All the paper you could get.
All the paper you could get out of that tree? Yeah, I guess, yeah, you could get a lot of paper out of that tree. Yeah, it's cool. It's in the redwood forest. That's actually in California. It's in my state. I don't think I've been to the redwoods. I've been to Sequoia. Sequoia has the biggest trees, I think, by volume, because they're really like wide, girthy, or whatever you want to call them. Yeah, don't worry, Ayush. I'll get to the bond coins. I do this on Sundays. You used to live in Sacramento. Yeah, so you probably could have gone to this. Yeah, it's a crazy big tree. All right, go away, Olaf. All right, let's see. Use a calculator. Round the answers to the nearest hundredths. Given the function here, find the following if they exist. You've been to more roots? Oh, that's cool. Yeah, John Muir, right? Is that how you pronounce his name? Muir? John Muir? He's a really cool, like, nature guy. Talks a lot about Manifest Destiny. Was he Manifest Destiny? Or he just talks about, like, going into the woods. Like, he's a really cool guy. Nature's great. Yeah. Okay, that's okay. You just want to check if you got the answers right? All right, well, let's just do it. That's easy. All right, you get to use a calculator, so fuck it. We're going to use a calculator. Because you could solve this without a calculator, but it requires calculus, which I don't think you're taking. 6x squared plus 5x minus 7. Let's trace this thing. Let's see what she looks like. Boom, 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 boom. Okay, cool. Now, how you can always check to make sure we're seeing the entire graph here is you should know, based on like the degree and the power of this thing, what it's going to kind of look like. So first of all, this is a cubic, which means it has 2 turning points. Like whatever the highest degree is, you subtract 1 from that, and that's the amount of turning points. And you can kind of see that here. Do you see how like there's a turning point here and there's a turning point here? Okay, so we see both the turning points. And then because it's odd, and because it's positive odd, you know it's got to go from down to up. So as long as we can see those two things, right? The all the way down, and we can see the all the way up, then we know our window's okay. If we were, for instance, like zoomed in like way too much, I don't know, like this, now you're not seeing all of the graph, right? Which is going to be a problem when you're trying to find like intervals and stuff. So always, Z standard usually works pretty well here. But that's just a check. Yeah, okay. All right, zeros. Way to calculate that. Just go to second calc, go to 0, and then you got to choose bounds here. Bounds are just like, you know, what's the border on the left and the right. So I can just click like there to there. So that should have gotten you negative 4.57. There's gonna be another one. Second calc. Zeros. So you can go from here to here. I guess your next one, which is negative 2.14. And then we got one more. Do you get this calculator, Adarsh, on your exam? Is this the type of graphing calculator you get? I probably should get some other emulators for like Casio and stuff. And this is 0.714. Okay, cool. All right, good. Well, this is the calculator you get, then you're fine. All right, the y-intercept, that's easy. You don't even need a calculator for this. The y-intercept is just where x is equal to 0. So if you plug 0 into this, that just gets you negative 7. So the y-intercept is at 0, negative 7. It's RPN, dude. RPN is, dude, I've always wanted to learn how to run an RPN calculator. It's called reverse Polish notation, right? Yeah. It's a weird way of doing math, but apparently it makes like a lot of sense. Okay. It's like you do the math like backwards, I think. It's like you do 5, 3 plus, and then it's like 6 minus minus, and then yeah, there's it's like being a stenographer for typing. Like it's really efficient, but it's kind of hard to learn the language. It's stack based. Yeah, okay, that's cool. Yeah. Do you know how to use an RPN calculator, Zach? Oh, they're endar. Yeah, endar 2, enter 2 plus. Interesting. So like the enter is like, okay, do the command, and then it's 2 plus. Wow. Oh, wow. That's super dope. Yeah. I've heard it's a lot better with order of operations. Ooh, okay, yeah. I was about to suggest our next thing we need to do is have a competition, but it sounds like you would just win. Maybe we have a competition and you're the judge. Like, we have a challenge where like me, Penn, and like Eric or whatnot have to learn how to use RPN in a week, and then see who does it well. Oh, way out of practice. Okay, maybe it's fair then. Okay, to find maxes here, just hit max. Again, left bound, right bound. So that's gonna be at negative 3.5, comma 6.13. He says he has tests. Ooh, yeah. You have like competitions we could do. That'd be kind of fun. Same thing for min. You can literally just go down, be like minimum. Do it. And that's negative 0.47, negative 8.12. Now, here's the interesting thing. When it says absolute maximum, I'm tempted to say that's positive infinity, right? Because it goes all the way up to infinity. But I've seen some teachers say that, like, it doesn't exist. That, like, there is no absolute maximum. Because, like, positive infinity is not real. So you tell me, Adarsh, whether you can say, like, positive infinity or does not exist. And then this I would say negative infinity or does not exist. You know, it depends. Okay. So the intervals of increase. So that happens from negative infinity down here all the way to wherever this relative max was, which was what? Negative 3.5. Oh, okay. So wait, do they say positive infinity or do they say does not exist? Oh, does not exist. Okay, cool. All right. Yeah. So there is nothing. Okay, cool. So anyways, increasing is from like negative infinity, like all the way over to the left here, to where we hit the relative max, and it's also from the relative min here all the way to positive infinity, which means the interval decrease. Well, that's just in between these 2 points. That's where it goes from here down to here, and so that's going to be negative 3.5 to what is that? Negative 0.47. Intervals of positive. That's between the zeros here, and then from here onward. So that's negative 4.57, negative 2.14, and then also from 0.714 up to infinity. Whereas negative is going to be from negative infinity to negative 4.57. And then from the same, what is it? And then from negative 2.14 to 7.14 or 0.714. Oh, good to see you, Shantrix. Yeah. Yeah, appreciate it. Yeah. You have a good morning or good evening. I forget what time zone you're in. Yeah. Okay, cool. That's it. Does that kind of make sense? How we got all of that? Oh, it's 9:53 over there? Oh, okay. Oh, yeah. All right, so you're just 4 hours ahead. All right, that's okay. Yeah. So again, yeah, right? You know, positive happens like here, all the way out to here. Negative happens just between here and over here. And then, like, increasing is here. Decreasing is here. And then max, min, and whatnot. Yeah. Hopefully it should make some sense. Yeah. Cool. All right. Nice. Good job, Aditi. Okay. Ace, you still around for one question and then Smash? I'll do the rest of yours. Yeah, you're very welcome, dude. Yeah. Congrats, dude. Good luck on your exams. You got all those right. Sick. All right, let's do this. All right, and then Smash. I'll help you with because yours is gonna be kind of a longer one. I saw it. We'll do it. Okay. A motion sensor, a pendulum swinging back and forth. When the pendulum is closest to the sensor, it measures 15 centimeters. And when the pendulum is furthest away, it measures 25 centimeters. It takes 1.8 centimeters to return back to its initial position. Oh, this is kind of whack. Because, I mean, your teacher here got depth wrong to start with. This is like the sensor. Right. The issue is that, like, it's gonna, like... Like, is the sensor measuring this distance all the time? Because technically this thing is gonna dip. It says this is 15 centimeters. This is 25. I think the horizontal position still follows like a cosine function at this point. Yeah. Okay, and then it tells me that the period is equal to 1.8. Okay, cool. All right, fine. So, easy, right? Midline's going to be at 15. No, sorry. Midline's not at 15. Midline is where this thing oscillates between, which is the average of these two, which is at 20. Okay. And then it has a low point of 15 and a high point. Draw dash lines today. High point of 25. Okay. Great. And it starts here. And then 1.8 seconds later. So make this 1.8. We'll make this, and then 3.6 is going to be the same, right? It's going to be there. It's going to be there. So then I draw like the half point. So 0.9, it's got to be at the max. Which means this is at 2.7. And if you want the halfway between that, this is going to be 0.45 is where this is going to be. And then I guess this is 1.35. And then what is that? 2.25. 3.15. Nice. Oh, what happened to our lo-fi music? The fuck? Stop playing? Oh, it's buffering? Oh, weird.
Oh, hi.
There we go. Whatever. Okay. Okay. 1 second. Let me pull it back up. And then they want an equation for the graph. Okay, so go wave all off. Great. So an equation for this. Again, it's a negative cosine, right? Because it starts at the max. So you know this is -5. The amplitude's 5 because it goes up and down. So this is -5 cosine, and then the period is equal to omega is equal to 360 over the period, which is 1.8. So that's going to be equal to, what was that, 200? So that's going to be 200 t and then plus 20. I think that's it. Oh, 25 is the initial position. Ah, thank you. Oh, I screwed up then. Okay, well. Take this whole graph and just move it that way. Okay. If it's the maximum, then just do this. Make this positive, and that's fine. Yeah. Yeah, that's it. Cool. Nice. Nice. All right, Smash, which one you need help with?
Well done! Well done!
5 and 11, real quick. All right, that's cool. Oh, we got time. Yeah, Zach's stream doesn't come on for another 30 minutes. All right, find the volume of the solid generated by revolving the region bounded by the graphs of the equations. Fun. Love this. About the x-axis. Okay, cool. So the x-axis is this one. So this is going to be our rotation axis. So whenever I see this, I just automatically know I'm going to be doing dx. But then let's try to make like what these graphs look like. All right, so y equals 0. That's going to be this, right? X equals 2. X equals 3. Okay. And then 9 minus x squared. Ooh, interesting. So this looks like to me like negative x squared plus 9, which is gonna look something like this. So I usually want to like plug these points in to see like where that lands, because I know it's gonna start somewhere up here at 9, but I want to know like where it hits on these things. So I plug it in. So for x is equal to 2, that's negative 4 plus 9. That's equal to 5. Okay. So that's going to hit here at 5. Okay, I got dash lines. Okay. And then if I plug in 3, oh, that hits 0. Ooh, love that. That's cool. So that's here. Okay. So I know my line looks something like this. Okay, very cool. And we're revolving around this axis. So now my radius is going to point from here up to here. Which this is nice, because the radius is literally just the y-coordinate of this, right? Which we already are given, right? So in this case, like, this is r, but r is equal to the y-coordinate of this, so we're all right. So this ends up equaling the integral from start to finish. Because remember, we're going around this way, so we're building a bunch of these types of circles. So we're gonna go from 2 to 3. And then that's going to be just r squared. It's just pi and then just r squared, because there's no hollow point in this. So that's just going to be 9 minus x squared dx. And then this is an easy integral. This is the disks method. Yeah. Where this can sometimes get tricky is if there's another thing like in between it. And then we call this the washers method, because we're going to do like this circle minus this circle to get like the in-between. Yeah. Yeah. Where this gets tricky is if let's say, for instance, they wanted to rotate it about... Let's say they said rotating about x equals 2. Okay. So if they're rotating about this axis, for instance, now you have to do dy, and now your radius becomes kind of weird. So your radius is now, let me just show you what it would be. Your radius would now be this amount, okay, which is equal to whatever the x-coordinate on this graph is, right? That's the x-coordinate minus 2, right? Because the x-coordinate measures all the way out to here. And then this measures out to 2. So x-coordinate minus this would give me this if I were to rotate around this axis. And then to find the x-coordinate, you have to rearrange this, because this is the y-coordinate. So you get that x squared is equal to 9 minus y. So you get x is equal to square root of 9 minus y. It's technically plus or minus, but I want the positive one, right? I want the positive x. So yeah. So then your r would be square root of 9 minus y minus 2. And this becomes kind of a pain in the ass when you square it and then have to do the integrals because you're going to get some cross terms on things. And maybe some u substitution. Yeah, the washers. That's what I see as like the next way they would make it harder, Smash. Is they would tell you to rotate about x equals 2. You're allowed to use the calculator to do integrals? Okay, sick. Yeah. Yeah, so yeah, you can do these numerically. I think there's an integrate button somewhere. Where is it? Like second calc something or something. I don't know. Under math. Is it fn int? Is that what it is? One of these like allows you to integrate. Yeah, cool. You just need to know how to set it up. Then yeah. I mean, and that's the main important point. That's the juice. That's the squeeze. You know, if you know how to set it up, then you're good. Okay, let's pull up your next one with 11. Yeah, the other one is the shells. I do not like the shells method. That's the like 2 pi r times the L. So I think, for instance, and I feel like you can do everything with washers and discs. You don't need to do shells, but yeah, if you do shells, cylindrical shells, then what you end up doing is like building a bunch of these, I think. Yeah. Well, they make you do this method. This method sucks, honestly. Well, it's not intuitive to see, but what you end up doing is you end up going up this way. So now it becomes dy, and it's integral from, like, in this case it would be 0 up to 5, and then it's 2 pi r, or no, so it's 2 pi r, which r in this case is the y coordinate. And then it's 2 pi y, and then it's times the length, but the length is this, which is like in this case it's the this, right? It's the square root of 9 minus y minus 2. Yeah, it's so much uglier. It's not a very nice one to do. Is your teacher gonna... Well, kind of. So, you're taking the circumference of a cylinder. Sorry, you're taking the surface area of a cylinder is what you're doing, right? Which, minus the top and the bottom, right? The surface area of a cylinder is this part, which is their circumference, 2 pi r, times the height, which is L. The amount you're going out ends up being just y. That's why it's that dy. And then I think this is the height. So the height changes as you build the cylinders out further and further. Let's see if there's like an image of this one sec. Cylindrical shells method. Let's see if they got like a... Yeah, it's this. So you end up building this cylindrical shell, and you're finding like the surface area of that shell as you're expanding out. With the washers and discs method, you're finding the area of like a circle or the area of a washer, and then you're expanding it out. This is like you're finding the area of. Okay, yeah. Put one in there. I'll do one. I'll do one next. Yeah, it's a good thing to practice. Honestly, I fucking hate these, but you know. Yeah. What is the 2 pi r times h dx exactly? Yeah. Yeah. I know how this is gonna suck. It's gonna suck. I really don't like the shells method, but love learning new things. Okay, well you're gonna learn some new things with us. Okay. Yeah. Put one of those in. Awesome. I see that. Okay, that does suck. We'll do that. Here, let's do this one though. Coal's burning. Okay. Coal's burning in a furnace. Oh, who's still burning coal? Thus exhausting the resource. The rate at which the coal burning is this. Okay, added to the furnace is this. Stops adding after that. T equals 0, there's 500 moles. Find the total amount of coal. Okay. I gotta think of what variables I want to use here. Burning, added, and we want to know how much coal there is. Okay. I'm gonna call the amount of coal A. Okay. So dA dt, the change in the total amount of coal, is going to be the positive rate going in. So this is gonna be rate in minus rate out, which in this case is going to be S of t minus B of t. So that's equal to 11 plus 10 cosine ugly 4 pi t over 25 minus 8 sine t over 2 pi. Does that make sense so far? So the total rate is the rate in minus the rate out. Yeah, okay, cool. Dope. Nice. All right. Okay, so that's dA dt. So what I can do is I can figure out what A is by integrating both sides, okay, with respect to dt. I just like basically move this dt to everything here and I just integrate. So that gets me that A is equal to 11t. Integral of this, that's u sub. Okay, so that's 11t, and that's plus 10, and then that's 25 over 4 pi sine of 4 pi t over 25. Did that make sense how I did that? I did some integration in my head there. But this is basically u sub. Basically whatever's inside here when you're integrating, it's like the reverse of the chain rule. But instead of multiplying by that, you multiply by the inverse of it. Yeah, okay, cool. You get it? Sweet. Alright, nice. Yeah. For those that don't know, for instance, if you had sine of like 5t, then the derivative of this would be cosine of 5t times 5. And this is how the chain rule works. You just multiply by the derivative of what's inside. The reverse happens for integrals. If you wanted to like integrate this, then that becomes, well, integral of sine is negative cosine 5t. And now you multiply by 1 over 5. So you multiply by like the inverse of the derivative. Or the reciprocal, sorry. That's what I meant, not the inverse. As long as it's simple. Okay, cool. And then this is plus 8 2 pi cosine of t over 2 pi. Yeah? Oh, and then this is plus c. Okay, so yeah, here's the rub, which says that, okay. Oh, wait, whoa. Oh, they don't start adding it until 2 hours in? Really? Dude, what are they doing with us here? Oh, this is such a clusterfuck of a question. Oh, sorry, because the times at which the stuff is being added and subtracted is not at the same time. Okay. I'm gonna take this somewhere else. This is why we read the whole question before we start doing questions. Before we start doing the question. Because, this is, because, again, I've seen so many of these questions that this is usually what they ask for next, but they were being kind of tricky with this. Yeah, not very nice. I'm really sad.
Oh no.
Oh, no. Stupid, dumbass question. Yeah, I know. Well, it's okay. They're trying to trick you. Okay. Let's just find the amount of coal added by the worker. Okay, at t equals 2, he starts adding, and then he stops at t equals 5. Okay, so adding is S. So if we integrate the adding from 2 to 5 dt, that'll get us the total amount that's added. Okay, so that's going to be 11t plus 10 times 25 over 4 pi sine of 4 pi t over 25. All is evaluated from 2 to 5, which honestly that sucks. Yeah, that's just ugly. But okay, that's the amount that's added by the worker. You just gotta plug numbers in. I mean, like, what? Ugh, it's gross. Okay, says, is the amount of coal in the furnace increasing or decreasing at 4 hours? Okay, that's cool. All right. Is the amount of coal in the furnace increasing or decreasing at t equals 4 hours? Explain. Okay. Okay, I assume t is all relative to t equals 0. Oh, thanks, Raven. Yeah, I like the flute. It's kind of fun, right? Okay, so I think we just look at S of t. I think we just look at, okay, we just look at S of 4 minus B of 4, and we see if that's positive or negative. Right? Because this is positive. This is the rate going in. This is the rate going out. So, what? That's 11 plus 10 cosine of 16 pi over 25 minus 8 sine of 8 sine of 2 pi. Right? Because it's 4 over 2 pi. Oh, no. It's 2 over pi. I'm going to guess the rate is increasing because this is 11. I guess this is halfway. This is basically pi over 2. So it's like slightly negative. And then this is slightly positive. I think it's still positive. Whatever. Basically do this. Do S of 4 minus B of 4. See if that's positive or negative. Find S prime of 3. Okay, well that's easy. That's just going to be the derivative of cosine, which is negative sine. And then times the power rule, right? So that's negative 10 4 pi over 25 sine of 4 pi t over 25, and then plug in 3. And then the units of that, so that's going to be pounds per hour squared. That's the units. Because you already had, so like S of t was already equal to like d col dt. And then if you take another derivative of that, now you get d squared col dt squared. This unit is squared. So now it's col per unit squared. Oh, thanks, Mondo, for the sub. I like pie. What's your favorite type of pie, Mondo? Mine is like apple, cinnamon, pear. I'm a big fan of that. I hate pumpkin pie. Gross. Key lime. Yeah, key lime is solid. Yeah. I mean, if we're really going there, I could say like chocolate pie. Key lime is fucking bomb, though. Or like lemon meringue. Lemon meringue's really good, too. That all sounds balling. Yeah. Pumpkin pie is very overhyped. I just don't like pumpkin flavored things. It's like when the PSL comes out and all the white girls like start flocking to Starbucks. I'm like, what? Not for me. Banana cream is solid. Yeah, okay. Yeah, banana cream is good too. Yeah, nice. I mean, any cream pie is great, right? Kecked up. Yeah, so the meanings... so the meaning in the context of this problem is this is like the change in the rate of the coal that is being added, which in physics terms, this would be the acceleration. You could also think of it as the concavity of the amount of coal being there. Yeah, it's the rate at which the rate is changing. Which is weird. It's kind of weird to think of it that way. Okay, write a piecewise function that gives the total amount of coal burning in the furnace at any time 0 to t minus t. Okay, cool. Yeah, okay. Yeah, I kind of see how this works because it's only burning between 0 and 2. Boolean logic. What's up, Lewis? Lewis, if you want to drop a screenshot in our Discord, just here, come to our Discord. And there's a channel called Help Screenshots. You can drop a screenshot of your question, or you can type it out there in the chat if you want. I'll take a look at it. Okay, so we know it starts at 500 at the beginning, right? Okay. So for t is between 0 and 2, right? We know that's going to be equal to 500, and then it's minus the integral from 0 to t of just the amount that's burning. So that's going to be the 8 sine t 2 pi, right, dt. You can do this integral. I know you can do it. Okay. Now, between t equals 2 and t equals 5, now the person is adding coal while it's subtracting, okay? So between t is 2 to 5, now this is equal to, it's equal to whatever this number is when I do this up to 2. So this is going to be like the amount at 2. And then it's going to be plus the integral from 2 to 5. And that's going to be s of t minus b of t. No, not 2 to 5, sorry. 2 to t dt. And then from t is greater than or equal to 5, this is just going to be equal to the amount at 5, and then it's strictly just minus 0 to t 8 sine t over 2 pi dt. Cool. Yeah, so do you get, like, in order to get this, the amount, you always need, like, an initial amount, and then it's plus whatever the rate is. this initial amount has to be like what happened after 2 seconds. So you have to integrate this from 0 to 2. And then that goes in here. And then if you want to figure out after 5, you have to do this from 2 to 5. Get this whole amount and then plug it into here. Yeah, right? Okay, cool. I'm not going to do the math because it sucks. Find the min and the max. If you get a graphing calculator, it would be nice to just... You can just graph these functions, right? This will equal some function, right? This will be like f1 of t. This will be f2 of t. And this will just be equal to f3 of t. It's definitely not going to be here. I think the max will be somewhere here. If the amount you're adding beats out the amount that started. And then the minimum is definitely going to be... It's either going to be here or it's going to be here. Because how I foresee this graph looking, it's going to look something like... Well, first of all, it's going to like oscillate down. Because you have a sine function in here. Like the amount decreasing is oscillating. This is super trippy. But it's going to go down, and then like there's probably going to be some rise, and then it's going to go down again. This is what I imagine happens at 2. This is what I imagine happens at 5. That's, again, it depends on the magnitudes of these, though. I don't know. It depends on the exact numbers. If you want the average rate of coal burned, so what you do is you take coal burned. Okay. So that's going to be... Oh, okay. That's going to be the amount at 0 minus the amount at 8 and then divided by 8. That's how you get the average amount. Where this right here, this is A of t. So here, yeah, actually, this is how I'd write this. Just to like kind of give you make this is more rigorous. This is A of 5, and then this is A of 2, and then you remember how to calculate A of 2. Yeah, okay. Okay, after t equals 5, the coal continues to burn until there is 0 pounds of coal remaining. Write an equation involving one or more integral expressions that gives the time at which it is exhausted. Okay, so that's when 0 is equal to A of 5 minus... oh, and first of all, this isn't from 0 to t. This is from 5 to t. Minus integral from 5 to t. And then this is 8 sine of t over 2 pi dt. And then this is when coal 0. And then just solve this. Just solve this for t. Yeah. Does that make sense? There's a lot of parts here. This is just super annoying to do algebraically. Like, I could do this. It's a lot of computational stuff. You know what I'll do here for you, Smash? I'm going to download this for you so you can have this PDF. Smash him. So there you go. That's the work we did, so you can refer back to it later if you want to. Okay. Yeah, you're really good. All right, here, let's do this last one. And then I gotta go. I think. One sec. What am I teaching today? Oh, I fucked up. Yeah. Oh. Oh. I thought. Actually, I gotta go right now, Smash. Actually, sorry, I forgot I gotta teach a student at 6:30. Is that okay? If you're around, when's your finals? Your final tomorrow? Okay. Well, good luck on it. Let me know how it goes. If I have time, I might be able to do a shell method, but otherwise, yeah, I gotta run. I totally blanked on this student. Okay, cool. Okay, all right, here, let's end the stream out. All right, thank you everyone for coming to Actual Education Office Hours today. Had a lot of fun working with you guys. yeah, awesome. Fun times. Thanks for coming around. Our next stream is going to be tomorrow. That's going to be at, what's that? Yeah, 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. Make sure, if you've got any homework questions, last-minute final stuff, come on by. We'll help you out. Also, we have an AMA podcast guest on Friday. Super special person. They're gonna answer all your questions about college admissions and all sorts of fun stuff. So come on by, submit some questions to our Discord. And now let's see who else is streaming today. I'm pretty sure Zach should have started. So let's see. Go raid Zach. There's Zach. Is Zach up yet? Following. Come on, Zach. He is. Okay, awesome. Sweet. Okay, cool. All right. Let's go say hi to our friend Zach. Zach's a really great friend of ours. He does a lot of awesome math stream stuff and whatnot. He just got his PhD in mathematics. So big congrats to Zach here. Join the PhD gang. Otherwise, yeah. Have a wonderful rest of your Tuesday. We will see you guys tomorrow. Peace out.